Hello everyone, hope you are doing well. So today we'll learn how to solve more complex problems related to parallel lines. So let's start. So over here we need to figure out what A is, right? So first of all, as you can see, line AB is parallel to CD. We get to know that because there are arrows on the line. This line AB is parallel to CD. But we can't see a proper transversal which is touching AB and CD both, right? So first of all, what I can think of is that I can extend this BE. Why I'm extending it? Because I don't have a clear picture of transversal, a complete transversal, right? There could be other ways also for solving this. We'll be discussing two of them in today's class, right? So what I'm doing is I'm extending line BE such that it touches CD at point F. As you can see in the solution diagram, I have extended BE and it's touching CD at point F, right? Now, since AB is parallel to CD and now I have a complete transversal BF which is touching this BF which is touching AB as well as CD, right? So clearly using alternate interior angle property, what we have now is angle 1 equals to 50 degree. Where is angle 1? I'm assuming this angle to be angle 1. Now this angle 1 would be equal to 50 degree. Reason, AB was parallel to CD. This BF is the transversal. So obviously this 50 degree and angle 1, they are alternate interior angles and hence they are equal, right? Now from the figure, it's clearly we can see that in triangle CEF, this triangle I'm talking about, this CEF, this triangle CEF, one of the angle, this angle is 60 degree. Angle 1 I have just figured out it is 50 degrees, right? So if I figure out this angle, then easily I can figure out what A is. Reason, because this angle and A are making a linear pair. We have learned it in the second video related to parallel questions related to parallel lines and transversal. If you have doubt like what is linear pair, you can watch that video. I'll be providing the link to that video also below in the description box of this video. So coming back to the question. Yeah, so this was our angle 1 which we have figured out, which is 50 degrees. This is 60 degrees and I'm assuming this angle to be angle 2, right? And this was A. So in triangle CEF, from the figure it's clearly visible to me that angle 2 plus 50 degrees, 50 degrees is angle 1's value which we have figured out over here, plus 60 degrees which is already given in triangle CEF. There sum would be equal to 180 degree. Reason, angle sum property of a triangle, which is that sum of all the three interior angle of a triangle is always 180 degrees. So from there, if I solve this, I'll be getting angle 2 equals to 180 minus 110, which is 70 degrees. I hope that's clear. So angle 2 is 70 now. Again, using the figure, as I already told you, a linear pair is getting formed because angle 2 and A are getting formed at the same point E and making a straight line. So that's why angle 2 plus A, they are making a linear pair, so their sum would be 180 degrees, right? Angle 2 was 70, so it's basically A plus 70 is 180. So if I solve it, it would be A equals to 180 minus 70, which is 110 degrees, right? I hope it's clear to you. If you have doubts in it, what you can do is you can put your doubts in the comment box and I'll clear the doubts. Maybe I'll make another video to clear your doubts. right? And now let's move to the next question. It's an alternate solution to the same question. Like how can we figure out the solution of this question itself using a different method? As in maths, we have multiple ways of doing the same problem, but the beauty is if using all the methods, the answer would remain the same. Here also is 110, and the other one also is 110 only. So let's see the alternate solution now. You have the same figure with you, which is we need to find out what A is, right? So in this alternate way, what I'm doing, instead of extending the transversal, I'm taking the help of a line. I'm drawing a line FG parallel to AB. So basically what I'm doing is, this is your question figure. One second. This is your question figure. Yeah. This is your question figure. This is your answer figure. So what I'm doing is, I'm drawing a line FG parallel to AB passing through E. As you can see in the solution figure, I've drawn a line FG parallel, this is parallel to line AB, and it's passing through the point E. Okay. Now, there were already arrows on line AB and CD. It means AB and CD were already parallel. Now I've drawn a line parallel to AB. So by default, it would be parallel to CD also. Okay. So that's why I've written FG parallel to AB, parallel to CD. Okay. I hope it's clear to you. What I have done, I have drawn a line parallel to AB. Since AB and CD were already parallel, so FG would be parallel to CD as well, right? Why I'm doing so? Because I need to figure out what A is. So instead of using the transversal thing, I'm using another method, which is drawing a parallel line. Now, let's do it one by one. Okay. See, once I draw it, I'm naming, and now your angle 2, it has been split in two parts. It's not mandatory that the two parts are equal, but it has been divided into two parts. So I'm assuming one part to be 1, angle 1, and this part I'm assuming it to be angle 2. Now if I consider the first case, which is AB parallel to FG, I'm just considering these two lines, AB and FG, and the transversal, which is BE. Okay, so if I consider this, AB, considering AB parallel to FG, please focus on the diagram, and BE the transversal. If I consider only this much of part of the diagram, it's clearly visible that your 50 degrees and your A, this one, they are nothing, they are making alternate, they are alternate interior angles, right? And we know this thing using alternate interior angle property, that if two lines are parallel and two of the angles are alternate interior angles, then they would be equal if the lines are parallel. That's why angle 1 would be 50 degrees. I hope it's clear to you. So one of the part of angle A we have figured out. Now we just need to figure out the other part, which is angle 2, right? So how to figure that out? We'll be using the similar way, but on the other two parallel lines. Now considering CD parallel to FG. So I'm just considering these two lines now, CD parallel to FG. Now your CE is the transversal, right? So if that is the case, now you're the 60 degrees and angle 2. This angle over here, angle 2. One second, let me use a different color. This angle 2, they are making alternate interior angle, right? Angle 2 and the 60 degree. They are forming a pair of alternate interior angles, and again since the lines are parallel, so therefore using alternate interior angle property, angle 2 would also be having the same value or as its alternate interior complement, which is 60 degrees, right? So we have figured out the values of two parts which are completing our angle A. So from the first figure as well as the second figure, it's clearly visible that A is nothing but sum of angle 1 and angle 2, right? Let me show it to you. Yeah. So A is nothing, you can see over here. A is nothing but it's the sum of angle 1 and angle 2. Right? This is A. So from the figure I can write down A equals to 50 plus 60. Reason angle 1 was 50, angle 2 was 60. So A is nothing but 50 plus 60, which is 110 degree. So that's how we can use this method to fetch the same answer and figure out what A is. I hope it's clear to you. If it's not, you can ask in the comment section. For the time being, let's move to the next one, which is the last question of the day. Again, we need to figure out the missing one, which is A. Here also, this is your question figure. And on the gray one, this is your answer figure. Okay, I need to figure out what A is. Similar case, AB parallel to CD. But I can't see a complete transversal line between AB and CD touching both. But I can clearly see that this A, it's somehow making a complete angle if you look at it. So it means if somehow I figure out this part of the angle, this part, and I subtract it from 360 degree, because the sum of angles present in a complete angle is 360 degree. So if I subtract this angle from 360 degrees, I can easily figure out what A is, right? So my ultimate aim is to figure out what this angle is, the one which I have marked using red, right? Okay, and so to do this, what I'm doing, I'm using the method that we used in the previous one, using the help of parallel line. So let's start. What I did is, I constructed a line HG parallel to AB passing through E. So this is your line HG. I've constructed a line HG. It is parallel to AB. This HG is parallel to AB and it's passing through the point E, right? Now since AB and CD were already parallel, so if I am constructing any other line parallel to AB, it means by default it would be parallel to CD as well, right? Now, as we did the previous question on the similar lines, we are doing this one. First of all, let's just consider AB parallel to HG. If I'm just considering these two, AB parallel to HG, then which one is the transversal? Obviously, BE is acting as the transversal. If B, my focus as I told you was this angle, right? Now this angle, as soon as I constructed the line, has been divided into two parts. Let me name the parts. Let me name it angle 1 and this one as angle 2. So AB is parallel to HG, as I have written. AB is parallel to HG and BE is acting as the transversal, right? So you can clearly see angle 1 and 140 degrees. Both are on the same side of the transversal BE. Both are between the lines AB and HG. So it means they are co-interior angles. And we know that if the lines are parallel, then co-interior angles are supplementary. Supplementary means their sum would be 180 degrees. So from there, angle 1 plus 140 equals 180. And if I solve this, angle 1 is 180 minus 140, which is 40 degrees. I hope it's clear, right? Now, I need to figure out, half of the question is done, because to figure out what A is, I just need to figure out what angle 2 is, and then I just need to do one more subtraction. Now to figure out what angle 2 is, what I'm doing is I'm extending line DF. Reason being because a transversal was already lying between HG and CD. So I just need to extend this transversal. See, over here I've written everything. Let me first clear the screen a little. Okay, let's have a clear picture now. See, so what I'm doing is I'm extending line DF such that it touches HG at point O. Let's focus on the diagram. What I have done, this DF was there up till here only. Now since we have a parallel line HG, this line, that dotted line, this HG, parallel to CD, so I can easily extend this DF. This DF I'm extending. I've extended it such that it touches point O. Now this DF, basically your OD, it's acting as the transversal between the line HG and CD, right? Is it clear? So if that's the case, there would be some angles getting formed between HG and CD, which would be having the properties that parallel lines provide us. So if you look at it carefully, I need to figure out what angle 2 is, right? One second. This is not my angle 2. This one is angle 2. This one is angle 2. Right? So angle 2 would be equal to 70 degrees. Reason, alternate interior angles are equal when the lines are parallel. Since HG is parallel to CD, OD is the transversal, so angle 2 would be equal to 70 degree. Alternate interior angles are equal when the lines are parallel. I figured out what angle 2 is. Now, but my ultimate aim is to figure out this angle. Let me name this angle maybe as angle 3. Okay. I can clearly see in triangle OEF, focus over here, triangle OEF, this triangle OEF, angle 2's value I already know, I just figured out it is 70 degree. Angle 3 I need to figure out, but if you clearly look at it, this is 90 degree. So if some line is falling, this line EF, if it's standing at 90 degrees on line OD, so it would be 90 on left and right both. So this angle is by default 90. So I can write it over here that this is 90 degrees, right? Angle 2 is 70, this angle is 90. So I can use the angle sum property and figure out what angle 3 is. So 70 plus 90 plus angle 3 is 180. So angle 3 would be, if I solve this, 90 plus 70 is 160. So angle 3 is 180 minus 160, which is 20 degrees, right? I hope it's clear. Now, since the last step, since we have angle 3 with us and angle 1 with us, moving back to the first step for which we have done this much, for which we have come this much far. One second. Yeah. So, angle 1 plus angle 3 plus angle A. Please focus on that figure. Angle 1 plus angle 3 plus angle A. This entire angle. Second. Angle 1 plus angle 3 plus angle A. This entire angle is making a complete angle, right? So their sum has to be 360 degree. So angle 1 plus 3 plus A is 360, but we know that 1 is 40 degrees. We figured out 3 is 20 degrees. So we can substitute their values. So 40 plus 20 is 60. So 60 plus A was 360. So A is 360 minus 60, which is 300 degrees. So that's how we can figure out what A is. I hope the question is clear to you. So the best way to have a grip on this question, to learn how to do this, is to practice as much as you can, so that you can have an idea like how to solve it, because there are multiple ways of doing it, right? So that's all. Thank you for your time. If you have any doubt or anything, you can ask in the comment section. And there are I have uploaded 2 videos related to parallel lines and transversal prior to this video. You can have a look at it if you want to clear your doubts regarding the properties. The first video is for that. The second video is to solve some simple problems related to parallel lines and transversal. So if I'll be providing the link for both the videos in the description box of this video. You can watch that if you have any doubt. Okay, thank you for your time. Have a wonderful day. And if you like the video and if you found it useful, please do press the like button and subscribe to the channel. Thank you.